Okay, so let's move to another topic, the indeterminate form 0 over 0. So sometimes the limit gives 0 over 0 form for rational functions. So to find the actual value, one should find an expression equivalent to the original. So this is commonly done by factoring or by rationalizing. So example, the limit of x squared plus x minus 6 all over x minus 2 as x approaches 2. So the denominator here, as we evaluate it, so 2 minus 2 is equal to 0. And then, for numerator, x squared plus x minus 6, that's 2 squared plus 2 minus 6, that's 4 plus 2 minus 6 is equal to 0. Our numerator is equal to 0 as well. So this is an indeterminate form, 0 over 0. As you punch in that values in your calculator, you can see that your calculator answer is as undefined, or you may think that this is the limit does not exist or DNA, but that is not the case. For something like this one, this kind of function, you have to check, you have to, so you have to find ways how to determine the exact limit of the function. So this is done by, in this case, through factoring. So x squared plus x minus 6, we can factor this one. So x plus 3 times x minus 2 over x minus 2. We can see there is x minus 2 in the numerator and the denominator, so we can cancel this 2. So x plus 3 remains. So we could use it as our new function to determine the limit of the original function. So the limit of x squared plus x minus 6 over x minus 2 as x approaches 2 is equal to the limit of x plus 3 as x approaches 2. So we will substitute the value of x with 2. So 2 plus 3 is equal to 5. So the limit of this one is equal to 5. Not undefined, not T and E. You done it by doing your factoring. Another example here, limit of x squared plus 2x plus 1 all over x plus 1 as x approaches negative 1. By direct substitution or using the limit theorem number 1, number 2, and number 3, we could see that if we plug in the value of negative 1 to all values of x, the answer is 0 over 0. So this is another form of indeterminate form for our limit. So we could identify the true limit of the function using factoring. So x squared plus 2x plus 1. So that's the factors of the factor is x plus 1 and the x plus 1 or x plus 1 quantity squared. So we have x plus 1 in the numerator and the denominator. We can cancel them, leaving x plus 1 here. So we will use it as our the new limit of the function to our from our original limit of the function. So limit of x squared plus 2x plus 1 over x plus 1 as x approaches negative 1 is equal to the limit of the x plus 1 as x approaches negative 1. So we will substitute the value of x with negative 1. So negative 1 plus 1 is equal to 0. Therefore, the limit of the function is 0. Not undefined, not DNA, but 0. We have another example here. Limit of square root of x minus 2 over x minus 4 as x approaches 4. So the denominator here, x minus 4 is 4 minus 4, that's 0. While the numerator, if we evaluate the limit of the function in the numerator, square root of 4, that's 2. 2 minus 2 is equal to 0. So this is another form of indeterminate form. But this time, we cannot do factoring. There is nothing to factor here. We will use rationalizing since there is a radical sign in the x value here. So to rationalize, we will use the conjugate number of the function with the radical sign. So square root of x minus 2, the conjugate number or the equivalent conjugate number is square root of x plus 2. You just make the negative into positive, and that's the conjugate number. You multiply the conjugate number in the numerator and the denominator of your original function. So square root of x minus 2 over x minus 4 times square root of x plus 2 over square root of x plus 2. Next thing is that you will apply the FOIL method. First, outside, inside, and last. So square root of x times square root of x, that's square root of x squared, and then outer square root of x times 2, that's 2 square root of x, negative 2 times square root of x, that's negative 2 square root of x, and the last terms, negative 2 times 2, that's negative 4. You can do your shortcut here if you know your shortcuts in FOIL method, or the long one, just like this one. And then x minus 4 times the square root of x plus 2. Do not do your FOIL method here because we will cancel one of them later on. Okay, so the square root of x squared, let's simplify this one. We can cancel 2 and the radical sign leaving x. 2 square root of x minus 2 square root of x, this is 0, so cancel, minus 4. And then the denominator is x minus 4 times square root of x plus 2. So there is x minus 4 in the numerator and x minus 4 in the denominator. We can cancel this or deduce this one. So this is 1 over square root of x plus 2. And we will use this to identify or determine the value of the limit of our function. So the limit of square root of x minus 2 as over x minus 4 as x approaches 4 is equal to the limit of 1 over square root of x plus 2, this one, as x approaches 4. So we will substitute the value of x with 4, so 1 over square root of 4 plus 2, that's 2 plus 2, which is 4, so the answer is 1/4. So the limit of the function is equal to 1/4. So another example here, limit of x squared minus 1 over square root of x minus 1 as x approaches 1. Notice that in your denominator there is a radical sign here, so we can do rationalizing. But before that, let's have a direct substitution for the numerator and denominator. For the numerator, so 1 squared minus 1 is equal to 0, while the denominator, square root of 1 is 1, so 1 minus 1 is equal to 0, which is an indeterminate form. So we will rationalize first. So x squared minus 1 over square root of x minus 1. First is we will determine the conjugate number of the square root of x minus 1. So that's square root of x plus 1. We will multiply that both in the numerator and the denominator. So x squared minus 1 times square root of x plus 1 over, apply FOIL method here. So square root of x times square root of x, that's square root of x squared, square root of x times 1, square root of x, negative 1 times square root of x, that's square root of x, negative square root of x, and negative 1 times positive 1 is negative 1. We could simplify here the denominator, square root of x squared is equal to x, and then square root of x minus square root of x, this is 0, and then negative 1. You could notice that x squared minus 1 can be factor. Okay, so the factor is x minus 1 and then x plus 1. So x minus 1 times x plus 1 times square root of x plus 1. We could cancel the x minus 1 here, leaving x plus 1 and square root of x plus 1. And we will plug in the value of c to our value of x here, which is 1. So 1 plus 1 is 2. Square root of 1 plus 1 is also 2. So 2 times 2 is equal to 4. And this is the limit of the function x squared minus 1 over square root of x minus 1 as x approaches 1 is equal to 4. And that's the limit, 4.